Through the course of the Reducing Burdekin Sediments project, we've installed 5 automated gates. We're trying to hold water back into the landscape so we're not losing excess irrigation water into the shallow coastal wetlands, which act as natural detention basins come the wet season.
A lot of the systems we operate in used to be ephemeral in nature. Since the development of the water delivery system, a lot of them now are perennial. We're investing in this water infrastructure to actually improve the water control within the area. Previously, we used manual drop board structures and typically weren't able to control them properly. Essentially, either delivering not enough water or in certain times too much water. So this new infrastructure will allow us to deliver exactly what we need. Some of the major benefits are to reduce the weed infestation within those areas and return those systems back to their more natural state.
One of the objectives was improve fish connectivity, so fish moving from the saltwater reaches as juveniles up into the deep water wetlands.
In the region we've got approximately 50 freshwater fish species, and half of those are what we call diadromers, whereby they undertake a life cycle dependent migration between nearshore marine habitats, lower estuarine habitats and upstream freshwater habitats. The most well known of these fish in this region is the mighty barramundi, which spawns down around the river mouths between November and December each year. The juveniles, which aren't very good swimmers, then undertake a migration between 30 and 100 millimetres around that January to March period, which also happens to be our wet season. They then move up into these systems where they've got abundant habitat and refuge and food resources. They grow big, quickly. That enables them to reach a size where they're able to migrate back down to the estuary and stand a better chance at surviving, spawning and increasing our fish populations.
This rock ramp fishway allows the fish to swim up into slow moving pools, save their energy, and then swim up fast over these little ridges and rest, get their energy back, and then go back into the deeper water and keep moving upstream. If we just had the automated gate, the water will be running really fast and fish can't swim against that. This is in low flows. In a big flood, this would all get covered in water, but it's once the water drops back and goes into the slow flows is when the fish can move against the current. On this creek system, we're looking at the bigger picture. We're doing a range of activities which all relate to improving the water quality and the health of the creek system. We're working with a lot of the landholders along the creek system. We have gone through and removed a lot of the weed chokes in the creeks. We're removing the woody weeds that can overtake the natural vegetation. We're fencing off areas for seasonal grazing so we can remove the fuel loads of the exotic grasses.
We're also installing fences and conducting aerial shooting to stop feral pigs from damaging the wetlands and cane crops.
We want to use this creek system as a template to learn what we could do better and take it to other systems along the catchments.
The partnership between Lower Burdekin Water and NQ Dry Tropic has demonstrated that both environmental outcomes and economic outcomes for the agricultural industry can go hand in hand.